In this video, we will talk about visual word recognition. Visual word recognition is a huge field of study. There are thousands of studies, entire books devoted to it, and researchers are actively trying to find out how our minds manage to recognize the printed words, exactly how this works. We're not going to try and cover this field in any detail. I would just like to mention a few basic ideas that may help you navigate the readings. Visual word recognition usually refers to skilled readers, those who have already learned to read. For those who are still in the beginning of learning to read, for those who are still at the beginning stages, getting to visually recognize words fast and efficiently is the central problem of learning to read. In contrast, for skilled readers, visual word recognition is something that happens rapidly, automatically, without effort and thought, processing the meanings of the words with our language skills and focusing on understanding what it is we're reading. An important issue in understanding how visual word recognition works concerns how letters are processed. Very beginner readers clearly process letters one by one. However, skilled readers never do this. Still, it might be possible that the mind processes the letters serially, that is, one after the other, except so fast that we don't realize it. Most models of word recognition now accept that letters are processed in parallel, that is, they are recognized simultaneously. And in reaching this consensus, the phenomenon of word superiority has played an important role. The phenomenon of word superiority or pseudo-word superiority concerns performance in recognizing a letter. Under specific experimental conditions, where a letter is flashed very briefly, it turns out that it is faster to recognize the letter R when it is part of a four-letter word, such as this one, than when it is presented by itself. It is also faster to recognize a letter when it is presented in a pseudo word that is a plausible word. So this is a reasonable letter sequence that could be a word, than if it is presented in the context of a similar letter sequence that could not be a word, for example, because it's all consonants. This presented a very big problem to early reading researchers because it suggested that words are recognized before the letters that make them up, which sounds logically impossible. How can you recognize the whole word before you can recognize the individual letters in it? So working with this problem has led to the understanding that not only are letters processed in parallel, but they're also interactively processed simultaneously with entire words. It has also become very clear through work on visual word recognition that words are not recognized by their shape or in any holistic sense. Instead, they're recognized by recognizing the individual letters that make them up. It is possible to affect visual word recognition by using very unusual fonts, but that is not because the shape of the words changes, it's because the letters become less recognizable because they're less familiar. A huge amount of effort has been devoted to studying how fast words are recognized. If you look at the visual word recognition literature, you will see that most people are running various experiments in which the speed of recognizing a word is measured in some way, either by asking someone to press a button when they recognize a real word, or by asking someone to read the word and timing how long it takes until they start to say it or until they're done saying it. In general, people are very much preoccupied with how fast the word is recognized. And you might wonder, why do we care so much about this? The reason we care to study how fast words are recognized is that differences in how fast words are recognized can be telling about how words are recognized. So by changing specific aspects of words or by contrasting words with specific kinds of differences and measuring if that results in differences in how fast they're recognized, we can find out which factors affect visual word recognition and which don't. And then we can theorize about how processing takes place such that these factors have their effects. So studying the speed with which words are recognized and what they are affected by plays a very central role in visual word recognition research. In particular, one concept has been central in our theories of how we become skilled readers and what this implies about the recognition of individual words. And this is the concept of automaticity. You will probably encounter in any reading textbook the idea that one is a fluent reader when one is a fluent skilled word recognizer or reader by sight, which means that words are recognized automatically. But you will often find very little information about exactly what this means, and this is because researchers are not yet in complete agreement about exactly what this means. When we say that some process is automatic, we mean that it has a number of different properties, not all of which have to develop simultaneously or to the same extent. These properties are rapid, effortless, unconscious, and obligatory processing. And the fact that they can develop gradually and not equally means that a word can be processed more or less automatically on a sort of a continuum. Rapid and effortless are pretty much self-explanatory. When we read words automatically, we read them fast and without trying or without getting tired by trying. Unconscious doesn't mean that we don't know which words we're reading. It means that we're not conscious of how we're doing it. We have no intuition into our own mental operations that achieve the feat of visual word recognition. We look at a word and we know which one it is. So that's unconscious. Obligatory means that we can't help reading a word. If we see a word, we read it, even if we don't want to. And I'll show you an example of that. Before getting to the example, let me also mention a different conception of automaticity that has to do with resources. So how much of your mental resources you devote to a task. According to this view, an automatic process is one that doesn't draw on common resources, which means that there is capacity left for doing other things. Indeed, this is a very common approach in the reading literature, where many researchers believe that automatically reading words, that is, automatic visual word recognition, means that your mental capacity is left over for comprehension to take place. In other words, recognizing the individual words in the text is easy enough that you can focus on understanding the text rather than on reading the words on the page. A common demonstration of automaticity is done with the Stroop task. This is the Stroop task. Before I go on, you can pause the video and try to name the colors in which these words are printed. So you would start up here and name these colors like gul, grön, gul, and so on, and just go through all of them one by one. Try to do this as fast as you can and see how difficult it is. You can pause the video now and try. It's very difficult to get through this fast and without any mistakes. Why is that? Well, the general idea is that reading the words is automatic in the sense that it is rapid, effortless, unconscious, and most importantly here, obligatory. You can't not read the word even though in this case you shouldn't, because it's distracting you. It's interfering with your goal of naming the color. You're trying to say yellow here, but the word bread is red and is interfering with the yellow that you're trying to say. And this is slowing you down, and sometimes the conflict causes you to make a mistake. So what are some of the properties that affect visual word recognition? An important property is what is called orthographic neighbors. What are orthographic neighbors? Well, simply put, is words that are similar. What does it mean to be similar? In the older conception, it means words that are equally long and differ by a single letter. So, for example, one of many neighbors for the word cat is the word mat, because it exchanges the letter C with the letter M, so that's a one-letter difference, and it's still a word. And there are actually many more neighbors for the word cat. This was probably among the best things that people could do a few decades ago when the idea first occurred. However, today we have much more sophisticated ways of counting the similarity between any pair of words and quantifying the neighborhood of a word. It turns out that how many neighbors a word has and how frequent they are, if they are encountered more frequently than the target word itself, can have an effect on how easily, quickly, and accurately you can read this word. And in fact, this effect may depend on what you're trying to do with the word. There have been demonstrated some differences, for example, depending on whether you are trying to decide whether something is a real word, whether you're trying to read the word aloud, or whether you're reading silently. Researchers are very interested in orthographic neighborhood effects because they show that the other words that you know must be affecting your reading behavior, must be affecting your visual word recognition. So the question is, how is that possible? Why is it happening? How is your mind working during visual word recognition such that the other words that you know affect your performance on reading the one you're looking at? This means that visually recognizing a word should not be viewed as a task that concerns only the word that you're looking at, but should probably be viewed as a task of distinguishing among a possible candidate word and everything else that it might possibly be. This is a much more demanding task that depends a lot on which words you already know, and possibly implies that as you become more knowledgeable and you know lots and lots of words, there is much greater potential for confusion that your mind must be able to resolve by resorting to more efficient coding strategies and building higher quality lexical representations that can actually counteract the effects of neighboring words. The largest effects on visual word recognition are those of frequency. This means that words that you encounter more often are easier to recognize. You recognize them much faster than words that you do not encounter very often, rare words. But that's not all. When you learn the words also plays a role. It turns out that words you learned at a younger age, when you still knew few words, are easier to recognize than words you learned more recently. So in some ways, the stage of your mind at the time that you're registering a word must affect the way that this word is represented, so that when you learn a word in the context of less knowledge, makes this word more effective compared to when you learn a word in the context of very many other known words. Another very important factor in visual word recognition is length. Length effects consist in longer recognition times for longer words. So if a word has more letters, it takes longer to recognize in general, but not always. For words up to 5 letters that are very frequent, there aren't any length effects, or if they are very small. This suggests that for frequent words, everything is processed in parallel, so there is no effect of additional letters if the word is 3, 4, or 5 letters long. However, for longer words, length plays an increasingly larger role. And this role seems to be bigger for less frequent words and for less skilled readers, and also for readers in orthographies that are more transparent. Another important effect in visual word recognition is the so-called transposed letter effect. Transposed letter effects refer to the phenomenon whereby if you exchange the position of two adjacent letters within a word, it is very difficult to distinguish from the original word. So this is a correctly spelled word, and this word is almost the same, except that these two letters have been exchanged. It turns out that misspellings of this sort are very hard to detect. Researchers don't usually study this using proofreading experiments. Instead, they use priming experiments. Priming refers to the phenomenon in which a word is easier to recognize if you have seen it previously, recently. So if you've seen the word judge and then you see it again, the second time it will be much faster to recognize. Now, the interesting thing here is that the word judge is faster to recognize even if you previously saw this non-word, which is like the word judge, but with the two letters exchanged. It's as if the exchange of the letters wasn't noticed by your word processing system, and so it led to the activation and facilitation of subsequently recognizing this word. This is a very interesting phenomenon, and it turns out that is much stronger for inner letters. So letters that are not at the end, not the initial or the final letter. If you exchange letter pairs at the beginning or at the end of words, such that the first or final letters are affected, these are much easier to detect. But they're much more difficult for inner letters. This has led to the now commonly accepted idea that letter identity and letter position are recognized somewhat independently. This means that one part of your mind is recognizing the identities, which letters you're looking at, whereas a different part of your mind is recognizing where these letters are. And this information must subsequently be correctly combined for you to recognize the word. Or it may suggest that position coding, so recognizing where letters are, is done very roughly, at least at the beginning, as if you don't need to know exactly where a letter is compared to knowing which one it is. So these are very interesting phenomena that are helping researchers understand how words are visually recognized. A side effect of this kind of research has led to the supposed Cambridge study. You may have seen a message that circulated in the internet a while ago, which claimed that Cambridge researchers found out that it doesn't matter what order you present letters in, as long as you have all of the letters, that your mind resolves it and recognizes the word equally easily, no matter where the letters are. This is very obviously false, and it's amazing that anybody actually fell for it. And of course, there is no such study at Cambridge. Nothing like that ever took place. However, it is true that if you exchange the locations of two adjacent inner letters, this may be very hard to detect, and if it affects reading of the word, the effect will be very small. Finally, Another important factor in visual word recognition is morphological complexity. Words are composed of different parts, such as roots and suffixes, which may be derivations, inflections, or both, or they can be compound words combining more than one root into a stem before any derivations or inflections. So what is seen as a word on the page between two spaces may in fact consist of several distinct pieces. And one important question that researchers are working with is, how is this processed? Are our minds trying to recognize the pieces and then put them together? Are they recognizing the whole word and then getting the meaning through the pieces, or directly from the whole word? This is an active area of research that is not yet fully resolved. In general, visual word recognition is a very active and productive field of study, and we're making great progress understanding how our minds process visual words, hoping to be able to eventually help more effectively those who have trouble learning how to do this efficiently.